number 6 ni, okay, garden, okay, to be laid out in a rectangular area. Rectangular, what is rectangular? Okay, rectangular, and protected by a chicken wire fence. So now ada wire lah fence, right? Okay, a garden. Pattern of the garden is rectangular like this, rectangular, and then we have a wire, okay, and then we want to surround it using the wire lah, nak cover all the fence, right? So what is the largest, okay, soalannya largest possible area, okay, so we're going to find this one lah, area, okay. If only 100 feet of chicken wire is available for the fence, so means that, okay, total wire tu only 100, okay, from the wire tu total dia 100 length tu, panjang tu, we want to do the pagar surrounding the rectangular ni garden, that one we call garden lah, okay. So our kita ni say this is the pattern of the garden, rectangular. Kita nak okay, ni buat pagar, okay, senang okay, di pagar, so surrounding by the rectangular garden. So what is the largest area? So find the area. Our concern is area macam mana? Area, okay, area, okay, area. So from this one dia tak bagi length lah, apa benda, so kita sendiri select that one is X and Y and area. So the formula of the area apa? X, Y, right? Something like that lah. So kita discuss lah for number 6 ni. Right. Okay, number 6. So I introduce an acronym D. First thing, okay, draw a diagram. Okay, let's say mention apa? Rectangular. Imagine the rectangular diagram. The second is, okay, find the equation. Okay, so write the equation. Okay, okay, and then express the equation. Express the equation in single variable. Okay, and differentiate first derivative. Differentiate to find f prime lah. To find f prime, differentiate, and the second derivative differentiate, okay, to find double prime. This one to test whether confirm that what is maximum or minimum. So deduct. So for this one, number 6, okay, D, draw a diagram. So the question say that rectangular, the garden rectangular. So just draw rectangular. That is rectangular. Cantik. Okay, and then protected by the chicken wire fence. What is the largest possible area? So now, okay, from the diagram, okay, so kita nak, okay, find the equation. Write the equation. So write the equation. So nak complete, right? So talking about the area, the largest area means that you need to differentiate yang the largest or the smallest tu. That is area. Our aim is to differentiate this area. Okay, this area tak ada something length over width apa something like that, right? You have to do something kat sini. Let's say this is Y, this is X. The label kan garden tu. So rectangular confirm lah, this is X juga Y. So area is X times Y. This is the area. Okay, and the next step is express into single variable. Okay, so A is equal to X, Y. Get rid of one variable. Okay, so how to get rid? Check, baca lagi. Mesti, okay, ada relation, connection between X and Y. Baca lagi. What is 100? Okay, 100 tu apa? 100. Okay, feet okay, 100. What is the punya ni? This info. When should we use this info? Ini 100. So now, let's say imagine you nak buat fence kan, garden tu. So you have to surrounding kan. Ni surrounded ni, sini. Okay, sini and sini. Total all is 100. So how to relate between the variables? Apa dia tu sebenarnya? Ni. Tahu.
Luas madam. Luas.
Volume, area,
No.
perimeter, surface, apa? Apa dia?
2x plus 2y equal to 100.
No, you all ni. Cakap lah. Respond.
Perimeter.
Good. That is perimeter. Yelah, of course lah, imagine lah kan. In real world, you nak ni, okay, form a ni, garden, pagar, confirm kan. So, x plus y is equal to 100. 2x plus 2y is equal to 100. X plus y is equal to 50. And then let's say you want to get rid of y. Y equals 50 minus x. Then substitute. And then x. Dah substitute ni kan. Ni 50 minus x into single variable. Okay, settle. So actually kita expand lah. Expand. Okay, settle for the third part. Deduct. And then first is differentiate for the first. Okay, derivative lah. Because I have to find the largest area. So differentiate area with respect to x. The chosen variable. If one y lah. Kan? So differentiate minus 2x. Okay, the largest area, smallest area, largest area sama je. dA differentiate is equal to 0. Same procedure je lah. Follow je ni kan. And then implies that 50 minus 2x is equal to 0. 0 to show the largest area. Smallest pun sama. Okay. And then x is equal to 25. And you have to test, confirm. Tak, okay. When x is equal to 25, the area largest this apa? The area is largest lah. When x is equal to 25, you have to check lah, test and double check. That's why we need to use second derivative. Okay. A dx squared ni differentiate negative 2. Okay, negative 2. So this one is less than 0. Maximum, largest. Okay, so therefore, okay, the largest area, okay, when x is equal to 25. Okay, still not finished. And y is equal to 50 minus x. Okay, 50 minus 25 is equal to 25. So what is the largest possible area? So area is x times y. Okay, substitute lah 25 times 25. 65 ke? Okay, check answer. Okay, so that's that one lah. Using the deduct. Okay, diagram. Find the equation. Let's say kalau let's say volume maximum. Instead this one is volume. Talking about volume. Okay, now we're talking about area lah kan. And change to into single variable. Okay. And differentiate for the first time to find the extremum lah, minimum or maximum. And the second time to confirm the value, give the largest answer lah, to confirm je. Nombor sama je. Dia saja confirm. Okay, that was number 6. Number 7. Given that V, this is V, equals 10R minus 5 over 6R cubed, find the value of R that match V maximum. So, V maximum means we need to differentiate V with respect and find the value R. Value R as V maximum. Okay, and then first differentiate V, dV dr, and then find the value and is equal to that's number 7. So is V is equal to 10R minus 5 over 6R cubed. Okay, so to find V maximum, find the value R. Okay, find value R. Okay, that match V maximum. So differentiate V with respect to R. 10 minus 5 over 2 R squared. Then V maximum implies that dV dr is equal to 0. Then find this one. Okay, take this one equal to 0. Okay, and 10 minus 5 over 2 R squared is equal to 0. Okay, and R squared bring R to one side and is equal to 20 over 5, that is 4. Therefore, R is equal to plus minus 2. Okay, you get two values for R. Okay, and then you try to test the two values. Okay, using the second derivative. Okay, and then next is find the d2v dr squared to make sure when r is equal to -2 or r is equal to 2, then max V maximum. Okay, and differentiate this one, then constant 0, and then bring 2 is -5 R. Okay, and then substitute. Okay, when R is equal to -2, okay, dV d2v dr squared, okay, substitute -2 and get 10. This one is more than 0, so minimum V minimum when R is equal to -2. Okay. When R is equal to 2, d2v dr squared -5 to -10. One is less than 0. So V is maximum. So okay, the answer is conclusion. Okay, R is equal to that max V maximum. Okay, so settle for number 7. Cylinder. Can you imagine the cylinder? Cuma imagine cylinder. Okay, ini cylinder. Cube ni confirm this is apa? Volume, right? Okay, so now the problem is, okay, the material of top and bottom. Okay, top cost dia, bottom cost. Okay, top bottom cost dia RM 10 ringgit per meter square area. Okay, and the material for the side 8 ringgit per meter square area given volume. Okay, and the material nak buat okay, produce cylinder. Okay, top and bottom cost RM 10 ringgit kan, yang side sebelah tu RM 8 ringgit. Find the radius, cari radius ni, radius and height of the The most. Okay. Dia punya ni is the most economical. The most economical. Mesti the lowest. The cheapest, the lowest lah. Okay. Dah bagi dah. Ni. Dia punya surface kan. surface. So now, dia banyak bagi. Volume. Okay. Volume. And then, semua ni lah. Height ni. This is number 8. Cylinder, imaging rupa silinder. Ini kan silinder. This is a cylinder. Okay. R, radius. H, height, right? So volume. Formula for cylinder volume apa? Pi R square H, right? This is a formula. Okay. So given this one is equal to, okay, macam ni first nak buat ni, okay, asal nak introduce, okay, dia punya acronym D is first, okay, draw a diagram. This is D, draw a diagram D, okay, and the second is equation. Find the equation lah. Apa and the third is express into one variable. Here is check H and R, right? Okay, express in one variable. And then D1 D prime, okay, differentiate first derivative. And D double prime, nak check test whether maximum or minimum. Okay, differentiate for the second derivative. So now dia cakap pasal cylinder. Okay, so sketch, okay, draw a diagram. This is cylinder. Okay, and relate all the formula. Okay, volume. Okay, given volume, this one the volume formula. And the volume for this cylinder is 20 pi. Okay, 20 pi meter cube, right? Okay, this is the volume dia. Okay, so now dia nak form a cylinder that the cylinder, okay, should be the volume is 20 pi. Okay, dia nak form a cylinder. Okay, so from the material, kena beli material. Okay, so now sekarang ini kalau kita buka silinder jadi macam ni. Okay, kita buka the cylinder kan, dia macam ni kan. Okay, macam tu. So top bottom price dia, cost dia nak beli top and bottom, harga dia 10 RM 10 ringgit per meter square. Ayat dah habis. Per meter square. Yang side sebelah ni dia punya cost dia RM 8 meter square. So now find the radius and height, the most economical. So dia bagi the formula. Okay, tulis dulu apa yang bagi. S is equal to 2 pi r square plus 2 pi r h. Okay, this one yang ini 2 pi r ini dia punya ni kan, top and bottom. Okay, and this 2 pi r, how to get 2 pi r? Confirm yang ni, tapi how to get 2 pi r? Okay, check this one dia punya ni perimeter kan, perimeter ni 2 pi r ni h. So area for this rectangular is 2 pi r times h, right? Ni masa ni. So you imagine lah, nak buat baju kan, yang gegel lah. Okay, baju kurung top and bottom. And top tu 2 meter, 1 meter cost katakan RM40. Okay, yang bottom tu 1 meter cost RM10 katakan. Macam tu lah nak beli. Okay, baju. Okay, so yang ini surface, not involve cost. Surface. Okay, So this is actually equation. Part E ni. Ni. Equation ini. Dia cakap pasal about the cost. Nak cost, kita nak build a cylinder, kita perlukan surface lah, kata cut ke apa kan. Beli cut, okay, kita form a cylinder. Surface, kita cakap pasal area surface. Kita bagi surface ini. But the problem is related involve cost. So sekarang ini, yang ini, this one, kena carilah. Ni for top bottom ni, okay, 1 meter RM RM. So sekarang berapa meter? So R ni ratio ratio. So 2 pi R meter square ni, this one ni kan. So 2 pi R square times 10 ringgit is equal to 20 pi R square. Cost yang side dia pula ni, sebelah ni, 1 meter square cost is RM 8 ringgit. Okay, yang ni dia punya formula apa? 2 pi RH meter square. Okay, yang ni, yang the blue one ni, yang blue ni, okay, cost is 2 pi RH times 8 ringgit. So 18 pi RH ringgit. So kita talking about cost lah. Cost C, the most economical. Okay, means that involve money kan, money cost. And then substitute bukan substitute, just you have to add both lah ni. Yang ini plus ini. Okay, 20 pi R square plus 16 pi RH. Okay, ni ingat tu. This one is ni tadi. Okay, and this one for tadi side tu. Dah now involve cost from surface to cost. Okay, faham tak you all ni? Okay tak so far? Surface. Okay.
Baik.
Kan, so now kita cakap the soalan is the most economical, duit cost lah. So now settle EQ, kita go to express ni pula, express in one variable. So one variable before differentiate, express to one variable. Ini C, ada something the variable is, tekan C to 20 pi ni R square plus 16 pi R H, two variable. We need to reduce to one, either or H or R. Okay, so cari mesti ada connection, okay, info, okay, which relate R and H yang tak pakai lagi. Check. So ni yang first kali ni. Okay, first kali ni 20 pi, yang first kali So the info is 20 pi is equal to pi R square H, right? Volume So now R ini, okay, 20. So up to you lah nak apa, H lah 20 over R square. Okay, now substitute lah ni. Okay, so okay, 20 pi R square plus 16 pi R 20 over R. Okay, and then into a single variable before differentiate plus ini apa ni R senang. Okay, so now okay, the next is differentiate for the first derivative. Nak cari the value when that one is minimum lah, or maximum, same lah. You need to differentiate. Okay, so differentiate first derivative. Okay, differentiate this one with respect to the variable. Okay, so So DCDR 40 pi R minus T to 0 pi R square. Negatif kan? Negatif. Okay. Is equal to 0. So the most economical, okay, implies that this one is equal to 0. So ini is equal to 0. Okay. Mak, tak habis cerita. Okay, to be continue ni. Sekejap. 0 pi R is equal to 0. Okay, so cepat you tolong cari kan. 40 pi R 3 to 0 pi R negative 2 bawah. Okay, naik atas R cube 3 to 0 pi over 40 pi, and then this one is cancel 8. Therefore R is equal to 2. Okay, and check. Okay, ayo, you ada kelas kan. Okay, double prime. Cari D to C DR squared and check is it. This one confirm dah, tapi nak double check check and then substitute and cari. Okay, so DC DR equals mana? Okay, yang ni yang sini. Okay, 40 pi R minus T to 0 pi R power negative tu, right? And then, okay, find the second derivative. Okay, here this is the first derivative. Okay, find D to C dr square. Then, so 40 pi, okay, plus 640 pi R power 3 negative 3, and then substitute ni, substitute R is equal to 2 inside. That's whether if positive or negative answer. Okay, substitute plus 640 pi R cube, then confirmnya, okay, find the value, confirm positive actually. So okay lah, cari je ini, cari kan berapa? Ni 8 oh 80. Okay, so 1 to pi, 1 to 0 pi. So you kena write down more than 0 positive. So this one is minimum lah ni. Okay, more than 0 minimum. Okay, so confirm the minimum is the least kan, minimum kan. And then therefore conclusion, therefore, okay, so the find radius dulu kan. Okay, radius is R and find H pula. Before that, H 20 over R square. Okay, 20 over R square is equal to 5, right? Okay, and then therefore the most economical okay, when R is equal to 2 and H is equal to 5. Okay, check answer. Okay, so now using the meter. Okay, so meter lah, ni meter. Okay, settle lah. Dia find R and H. So settle for number 8. And this one number 9. Number 9 dulu, rectangular box. So imagine rectangular box. Okay, just rectangular box. Petak macam ni kan, rectangular. Macam rupa dia rectangular macam ni kan. Awak sengit kita buat tegak lah, senang. Okay, tegak. Okay, ni ini ke rectangle. Okay, box mestilah mesti bentuk yang macam ni kan. Ini okay, box tu 3D, dia is a box kan. Okay, kalau if 2D tak call box. Okay, this one is box rectangular ni, and from rectangular piece of cardboard. Dia form from a cardboard. Okay, and dia from here piece of cardboard which is 3 inches by 8 inches. Okay, so 3 by 8 inches. So now this cardboard ni size 3 by 8, dia buat form jadi a rectangular box. Okay, and then what is the size square should be cut from each corner. Size square is this is square from the box with the maximum volume. Now we concern about maximum volume yang maximum. Okay, find the volume and differentiate volume. Okay, differentiate volume maximum or minimum, whatever it is, differentiate this one. Okay, so now this is a piece of cardboard. Okay, size 3 by 8, and we should cut every ni corner. Kita cut at corner. Why kita cut at corner? Because of nak form, okay, nak fold dia punya corner-corner ni and form to be a box, rectangular box. Itu dia punya idea. So this is square lah, square, and what size square? So dia tak bagi variable. Dia say this is x lah, x. So this is x size. So now we going to find this lah, nak cari, and then this one volume. That's why I call the volume. From the box ni baru ada volume. Okay, ni baru two dimension, tak ada no volume, only ada area. Okay, so inilah. Okay, nak find ini jadi ni. Okay, jadi sekarang ada 9. Okay, so rectangular box. Okay, from before that, okay, yang digs kan. Okay, digs deeded, the acronym deeded. D, first thing nak tackle this question is the acronym deeded. Okay, draw a diagram, and okay, take the equation. Okay, write an equation for the inequality whose maximum target, maximum or minimum lah. Okay, kalau let's say volume lah. Okay, and then it express to single variable, and D1 is differentiate to get f prime of x, and find f prime of x is equal to 0 to find minimum or maximum. Okay, and D double prime to differentiate to the second derivative to reconfirm, to check for checking whether that was confirm maximum or minimum. Or this one called deeded. Use the acronym deeded. Now for the first D, okay, draw a diagram. Okay, the question say that a rectangular box. So imagine the rectangular box. Okay, ni rectangular box. Okay, ini rectangular box. Okay, and dia form from a rectangular piece of cardboard. Okay, this is piece of cardboard. Boleh lah. And then which is the piece of cardboard then 3 inches and 8 inches. Okay, and what is size square should be cut. Can you imagine a piece of cardboard you want to form to a box? Of course you need to cut at the corner, right? Cut at the corner. Yang ini potong. Okay, potong cut every corner. This is actually square. Dia kita form a cut at this one. Jadi square. So dah potong, let's say, and the box change to this form. Jadi macam ni. Okay, macam ni kan, macam ni. Okay, something like this lah. Imagine lah. Settle satu. Okay, baru kita fold the paper ni, fold kat sini, and for the paper and change to this box. Macam tu And then now what size should be cut at each corner. So let's see, this is X lah because of square. X, so all X, semua X. So the length kat sini sekarang jadi apa ni? Ni jadi apa? Okay, jadi apa? Jadi ni je. All 8, right? Ni all 8. So you want the green one je.
8 minus 2x.
Okay, good. So this one, ini je. Ni je. Dia apa? Ni je. Ni je. So, apa ni? Ini lah ni. Okay. So all 3, right? Intersect. So jadi apa ni? Sama lah kan? 3 minus 2x. So this one is 3 minus 2x. 3 minus 2x semua all sama. Okay. So this one also sama ni. 8 minus 2x. 8 minus 2x sama kan? So jadi kita form, jadi dia punya ni is 8 minus 2x. Ni yang sini 3 minus 2x lah. Okay, dia punya ni. So dia punya height dia apa ni? Sini is ni kat sini. Yang this one right, yang tak ada ni. Ni yang sini right. Dia punya apa call size dia kan. Dia punya length tu ada x lah, x. So sini dia punya ni is x lah ni. X. Kawasan ni kan. Ni kan x. Kawasan ni x. So this is x. And then 3 minus 2x, 8 minus 2x. Settle for diagram Settle for diagram. Dah imagine macam tu. And now EQ. And find the maximum volume. They're talking about volume. Volume, so kita ambil volume. Volume for this cuboid. So the volume is inilah x times 3 minus 2x times 8 minus. Okay, dia punya formula for the volume lah kan. Formula this one times this and this right, all to get a volume. So settle macam same like x times y times z lah macam tu kan. Okay, because of 3 different different dimension kan. Okay, so the third is the second E is express to single variable and check, oh this is in variable x, so tak kisah, tak lah. Okay, skip this one, skip because of the one is in the single variable. Settle kan. And the next is D1 or D prime, D1 lah. Okay, differentiate with respect to x. So actually better expand lah. Okay, or you can use product rule. Product rule kan. Expand, better expand. Okay, so 3x minus 2x square. Ni 8 minus 2x. Okay, expand How you want to use product rule? Macam mana? Expand. So is ini 24x minus 6x square. Alert Calculus ke apa? Ini okay. Ini minus 16x square ini plus 4x cube. And simplify lah sikit. Adjust jadi 4x cube. Ini minus 22x square plus 24x. Okay. This one kita pergi try dulu. Kita simplify right. Sini baru ada D1. D1 is differentiate for the first derivative. Means find dv dx. Okay. So 12x squared minus 44x plus 24. Okay, dah settle. And then the question 1, V maximum implies dv dx is equal to 0. V maximum ke or V minimum ke, everything differentiate is equal to 0. Okay, and then this one is we need to find x. X. Okay, it implies that 12x squared minus 44x plus 24 is equal to 0. Factorize. Factorize or simplify dulu. Simplify is it? First one is 4 3x square minus 1x plus 6. Factor tadi no. Okay ni apa dia? Check. 3x x 3 2 right. Ini minus. Okay, so 3 2 6. Okay, 3x is equal to 2 over 3. Okay, x is equal to 3. So, okay, check. Okay. Kenapa potong habis Okay, ini kena buat pula. Okay, tak apa. Laju sikit Saya laju sikit ni. Okay, so d2v dx square and ini di differentiate 24x minus 44 is equal to 0. Kita check and then when x is equal to 3, ini you all nampak sangat ni. Tak. Ni betul Okay. Okay, ini when x is equal to 2 over 3, substitute d2v dx squared is equal to 24 2 over 3 minus 44. Cari kan? Okay, carikan form ni.
Negative 28.
Okay, thank you. Negative 28. Negative 28 is negative So this one lah maximum. Okay. Try lagi. Ini when x is equal to 3, d2v dx square 24 3 minus 44. Apa? Carikan
28.
28. Thank you very much. Okay. And then more than 0 minimum. So therefore, okay, implies that V maximum when x is equal to this one lah kan ni. Maximum. Okay, when x is equal to 2 over 3. This one is minimum. This one is minimum. So we just take the maximum. Okay, when x is equal to 2 over 3. So the what size square should be cut. Okay, so size dia ni lah. X is equal to 2 over 3. So dia cut tepi ni x kan. Kaki tu satu. Okay. Ni. So this is x. Kawasan ni x right. X. Kita potong ni. Kita potong. Okay. Sini is x. Jadi potong semua. And then form a box. And the box give the maximum volume. Let's say if you choose this one, yang ini. You potong guna yang when x is equal to 3. Dia akan jadi paling minimum. The box is macam panjang. You boleh imagine kan. Yang ini maybe the box dia macam ni. Maybe the box dia katakan macam ni. Okay. Macam ni right. Okay. Yang ni. Yang this one. Okay. When x is equal to 2 over 3. Okay. Dia punya x. This one is x. Okay. Now let's say if you choose x is equal to 3. Yang ni. Yang 3 ni. So maybe the box is macam ni. Okay. Macam tu. Okay. The box dia. Macam tu. And this is x. Ni x. X is equal to 3. So dia ni yang ni bagi maximum volume. This one is minimum volume. So we choose this one. Settle for number 9. Number 10. Length of the wire. The length of the wire. Length panjang. But it's make a cuboid. This is cuboid. Shown below is 96. The total of the length is 96 lah. And then they form a cuboid. This is a cuboid. Find the maximum volume. Find the maximum volume instead to find the V maximum. Kita concern on V volume. Differentiate V with respect to something variable. Okay, this is one. So ini total length tu refer kepada apa? Total length. This one refer kepada apa? Okay. So total length dia buat dia form okay, this cuboid, framework rangka cuboid. Okay, rangka je So this one to, actually 96 tu refer to apa? Is it perimeter, area or volume? Ni refer ke siapa ni? Total line ni. Ini. Total of what? Cepat. Total of
Perimeter.
yes, good. This one total of perimeter. Okay, total all. Ini, this one is confirm lah 3x. 3x because of cube, right? Same length. So here is x. Sini x. And the height is y. Ini y. So from here dapat 4 times 3x. 1, 2, 3, 4. And 4 times x. And 4 times y. Total is equal to this one. So now to find the volume, maximum volume, the formula for volume is equal to this one times this times x. Okay, so discuss lah number 10. Okay, mana dia? Kenapa lambat sini? Kenapa slow? Sini je lah. Okay, so number 10. Okay, cuboid. Okay, cuboid. Okay, this is y. Confirm this y. And this one is 3x. Okay, 3x. And this one is x. Total length ni, total all, total length of the wire is 4 times x ni. Okay, plus 3 times 3x plus what? 3 pula 4 lah. Because 4 time, right? 4y is equal to 96. Okay, ini kan x plus x or 4x. Ini 3x. So 4 3x. Okay. Yang ini y. So 4y. Total is 96. And then so x plus 3x plus y divide by 4 dapat apa? 24. Check Aku kali lagi. 24 kan? And then 24. And then ini 4x plus y is equal to 24. And you can just leave it lah. This one is D. Diagram. Given diagram. And equation is volume. Kita nak volume maximum. So volume, okay, maximum volume x times 3x, okay, times y. This is the formula volume. Okay, and now change to one single variable. Express to one single variable. So when you express one single variable, you don't want to express x or y. That's why you need to find the relation between x and y. Mesti ada info, okay, to relate between the two variables. So this is the info dia lah. Info dia, okay, to relate between x and y. So now because of this one is equal 1 only, just get rid of 1. Okay, take this one as a subject. Okay, and now substitute. Then get 3x squared ni, and 24 minus 4x. Okay, and then this one, okay, times, and the answer is ni 24 times 3 apa? Maybe dah penat saya ni. 72 ke? Check 72x squared. Okay, minus 12x cube. Double check. And then okay, and then next is D. First D prime. Differentiate dv with respect to x. Ni lah single variable kan. So ini 1/4. Check 1/4. Okay, please check that one. Okay, I'm tired already. Ini 36x square. Okay, and then to find maximum or minimum. Okay, so now V maximum implies dv dx is equal to 0. V minimum pun also, this one is equal to 0. Always differentiate and is equal to 0. And itu je sama, same And then find this is, okay, you need to do solve for this one first. First this one, 144 x minus 36 x squared is equal to 0 to show that you're going to find value x. Okay, and then factorize. Ni factorize dapat apa? Check. If 36x dapat apa? Check. Is it 4? Check 4 minus x. Okay. And x is equal to 0 or x is equal to 4. Sekarang double check ni. Okay. Then settle. Then now the deduct, right? This is deduct deduct. Okay, find the second derivative to test is it when x is equal to 0 or x is equal to 4, the value is maximum. Actually, it is impossible x is equal to 0. Why? Because if x is equal to 0, okay, 0, so you got already 1. Y je. Y is a one dimensional. Dia tak form a keyboard. Tak ada. Jadi tak logic. But it's okay. Want to show is okay. To show je. So d to v dx square. Okay, v is ni. Okay, differentiate. Okay, so 144 minus 72 x. X. Then substitute. Let's say substitute lah. Nak substitute. Okay, nak juga. Okay, so d to v dx square 144 lah. And confirm dia one is more than 0. So minimum dah tak ada dah. Kan, because we need maximum. Okay, when x is equal to 4, d to v dx squared is equal to 144 minus 72 4. Cari. Cari apa? Apa? Is it answer is 144 ke negatif ke? Check. Is it 144 negatif?
Yes, doctor.
Okay, so this one is less than 0. Maximum. Okay, and then confirm lah. Confirm V maximum. Okay, V maximum when x is equal to 4. So the question find the maximum volume. So volume is formula dia. You can take this one. Take this one. Take this or this one. So I prefer this one, the first one. And then y is equal to 24 minus 4x. So 24. Okay, kita buat one by one. Apa tadi? X 3x y kan. And y equals lupa dah. 24 minus 4x. Kita check. 24 minus 4x. Okay, 4x 3. Okay. And then substitute 4. Okay, and then y is equal to 24 minus 3 and 8. Okay, here substitute. 4 join pun is okay kan. Ini 12 8. Cari kan? Carikan. Dapat apa? So answer is the answer is siapa yang cari? Tak ada siapa cari kah?
384.
Okay, thank you. Volume kan? Volume means cm cube. Dah done. Okay, settle. So this is deduct. Deduct. Deduct means that simple je. Okay. Cylinder, circular cylinder, image cylinder. Cylinder inscribed in a hollow circular cone. Jadi cylinder in the cone. Cone macam mana rupa? Macam ni katakan. Macam ni. or macam ni, cone. Okay, and cylinder, okay, inside cone. Or like this, like sini lah. Okay, baca lagi soalannya. And radius. So the radius and height ni belongs to cylinder or cone? Belongs to apa? Cylinder or cone? Cepat. Cylinder, cone of radius, right? Of radius maknanya dia belongs to what? Cone kan? Belongs to cone. So one end of the cylinder touch the base. Maknanya duduk sini touch the base. Touch the base. Okay. And the cone while the other end touch the curved surface the cone. Macam mana? Sekejap. Macam mana? One kena faham ni. Cylinder inscribed in the hollow cone of radius 8 and height 12. One of the cylinder, talking about cylinder, touch the base of the cone. Base of the cone ini, while the other end touch the curve of the cone. Mana curve dia? Okay, ini kan kertas ni, curve kan? And then if the cylinder has a cylinder yang ada the radius x, okay, cylinder dia ni radius x, show that the volume of the cylinder, talking about cylinder, volume cylinder is this one, show that. And maximum volume of the cylinder is 4/9 times the volume of the cone. Okay, ratio. Okay, ratio maximum volume of the cylinder. Okay, ratio volume for a cone is equal to 4/9. 4/9. Macam ni nak show. So means you need to find volume lah. Kita talking about volume. Volume maximum. So find the volume. Differentiate volume. Okay, now we need to differentiate volume. Okay, kena tahulah the formula volume for cone and cylinder. Ni, okay, D is diagram. Okay, macam mana rupa dia? Tengok macam ni lah. Kita choose this one. Okay, ini. Elok lah comel ni. Okay, and then cylinder. Okay, jadi cylinder. Okay, imagine. So the cone, radius cone ini ke sini, cone punya is 8 cm, and the height of the cone is 12 cm. So that cone is constant, tak ubah. And one of the, okay, settle. Then the cylinder has a radius. That cylinder has the radius. Yang ni radius dia ni, dia. Okay, x radius. Okay, radius. Okay, r is equal to x cm. Okay, and then show that the volume of the cylinder. So now let's say this is the diagram. Okay, and then EQ, the equation. The equation is volume of the cylinder. Okay, volume of the cylinder. Now volume of the cylinder is pi r square h, right? H, this one dah dari 12 kan, nak order h kan. This talking about a cylinder. Cone is fixed, the pattern is fixed. 12 height and 8 radius. Fit dia. Okay, the problem maybe on the cylinder lah. Okay, ni formula dia. So the problem is yang ini. Dia given that, okay, it's up to which cylinder. This one is x, right? X. Okay, it's okay. X squared. Then the problem is h. Okay, because we need to reduce to 1. Okay, to find the one single variable, to find this one v. Volume. Okay, so how to get rid of one of the variable r and h? R is given x. We want to get rid of h lah, because we need x, right, in variable x ni. Nak get rid of benda ni. So, and then check. Okay, from the given info, what is relation between the two variables r and h? Ni, kita check ni. So, saya kita detailkan this one. Ni, kita cut that one. Okay, kita cari macam ni. Let's say kita potong. Okay. Kita potong itu half Kita take this one Ni, ambil ni. Okay. Okay, take this one. Okay, this is cylinder punya kan. Okay, cylinder punya. And this is 12 Yang ni 12. And the first one is 8. Okay. This ni, yang this one X, R, yang ini cylinder X. And ni X. So, confirm this is X. Cylinder. Is it name as cylinder kan? Confirm dia punya pattern sama, right? Straight radius X. Okay. So, now we need to find H, okay, of the cylinder. H of the cylinder. Okay. So, not H of the cone. Cone is 12. Confirm dah. H of the cylinder. Okay. So, because of cylinder je ada variable berubah X and H. The cone fixed. Okay. 12 by 8. Macam ni lah. Kan. So, kita tengok ratio. Take the ratio. The ratio is take the dia punya triangle. One of the triangle yang ini. One of the triangle is confirm lah 8 and 12 cone. And another one is between this one or this one. Triangle. Check okay, kita check. Ini kat sini ni. This one is 12 minus H, right? Yeah. Atau this one is H ni. Okay. So this is X. Up to you lah. Nak tengok ratio between 12 minus H dengan X. Or take this one. Ini kita choose this triangle. Or take the another triangle. Okay. Okay ni. The second one ni. Okay. H. This part is 8 minus X. Okay, this is the second triangle. Okay, up to you. Okay, so we need to find ratio. Nak relate between the two variable H and R. Okay, and let's say refer to this one. We want to get rid of H, right? I think better take this one ni. See, because the H je. Kan? Yang ini dengan ni. Ini dengan ni. Okay, so ini dia ratio H over ini H over 8 minus X, okay, is equal to 12 over 8. Ambil ni D over ini is equal to 12 over 8. Okay, and H is equal to 446. Dah penat rupanya saya. Okay, kepenatan. 3 over 2, sorry slow sikit ni. 3 over 2, 8 minus X. Okay, check make sure you check pasal saya dah penat sikit and then substitute. Okay, substitute this one ni, H ni, substitute dari. Okay, so 3 over 2, 8 minus ni. Okay, and then simplify lah. 3 over 2 pi, yang ini X square 8 minus X. And then okay, done, settle. Okay, macam tu lah. Any problem? You all okay so far? Still okay?
Okay.
Okay, okay. Kita continue. Okay, settle. And then find the first D. Differentiate the first D. Differentiate to find maximum volume to find it one. dV dx. Okay, expand lah. Expand senang. Expand. Ini 3 over 2 pi 8. Okay, yang ini. Okay, so 12 pi x squared. Okay, and then minus 3 over 2 pi x cubed. And then differentiate 24 pi x minus 9 over 2 pi x squared. Okay, and to find volume maximum, implies dV dx is equal to 0. Always, okay, this one and then next step, 24 pi x minus 9 over 2 pi x squared is equal to 0. Okay, and then simplify. Okay, simplify or factorize. Factorize ni x. Okay, kita terus dulu. Okay, and then negative 9 over 2 pi x minus plus 24 pi. Macam tu. Okay, and x is equal to 0. Ni boleh take out lagi kan? Okay lah. Okay, so now 9 over 2 pi x is equal to 24 pi lah. Okay, 24 pi and fine lah. Simplify. Okay, until that x. Okay, x is equal to carikan 24 pi. Carikan for me 9. This one is pi, right? Potong. Carikan. Apa? Cancel 3. Okay, 8. 8. Tengok tu. Is it? Okay, 16. Please check for me. Cancel. Ada sound check? Ada ke? Tak ada. Check kan for me. Okay. Betul ya? Kalkulator check. Saya tibai je ni. Saya tu je. 3, 24, 8, okay, 16, okay guys. Okay, and then check, find the second derivative. Okay, dv, d2v, dx squared. Mana dv dx? This one lah, take this one kan. Okay, and then 24 pi minus 9 pi x. Substitute lah. Dia ni tak payahlah, no need lah ni. Tapi tak apalah, buatlah juga. Okay, confirmkan. When x is equal to 0, d2v dx squared. Yelah, when x is equal to 0, tak ada no ni lah. Silinder kan? Kan silinder dia punya radius x. Okay, saya actually dah ignore je. Tak apa tunjuk ni. Okay, and 24 pi. Okay, more than 0. Minimum pun. Okay, when x is equal to 16 over 3 d2v dx squared. Okay, 24 pi minus 9 pi 16 over 3. Please help me. Cepat. Okay, this one 240. Cepat. Berapa? Cancel. 3, 48. Is it negative 24? Check. Betul tak? Oh, tak bantu ke saya ni? You all bantu tak?
Betul.
V maximum, V cylinder maximum is when x is equal to 16 over 3. Okay, settle. Nah, dia kata maximum volume. Cari maximum volume lah kan. Volume for cylinder. Kita settle kan, volume for cylinder. Mana? Ni lah dah bagi A. Take A. Volume for cylinder 3 over 2 pi 16 over 3 square 8 minus 16 over 3. Okay, and tolong cari. Okay, soalan cari V kon. Ni silinder kon. Tak apalah. Kon 1 over 3 pi r square h, right? So substitute lah. 1 over 3 pi r is kon is r is 8 and the punya height is 12. Tolong cari.
256.
Yang ni atas
1024 over 9.
1024 over 9.
Over 9.
Okay, 1024 over 9 pi over 256 pi. Okay, now carikan 1024.
Dapat over 9.
Okay, so now actually mesti because our data show in 4 over 9. You have to find in fraction lah. 4 over 9. Okay, so dia punya ratio V cylinder V cone is equal to 4, 9. Sure lah. Okay, settle lah. Settle for this one. Okay, ingat dah. Should be this one in fraction, not in decimal. In exact number. Senang and then make sure, because of why? Because our aim is to get 4 over 9. Okay, so make sure you have to give the exact value. Okay, settle.